Perfect. Thank you. All right, everybody, thank you very much for coming here. Hope that I can keep you awake for the next hour. My name is Jerry Miller. I'm the founder of Cloudticity. We help healthcare companies design, build, migrate, manage, and optimize HIPAA-compliant solutions on AWS. We've been doing it for about 8 years, exclusively healthcare, exclusively on AWS. And during that time, we've kind of discovered a few things about HIPAA compliance and adherence to compliance frameworks. So I'd like to share a little bit about what we've learned. Hopefully that's useful to you. So we're going to get very deep technically later in the presentation. But I do want to start by setting the stage and talk about why compliance is important in the first place. I want to talk about how to approach compliance with standardized compliance frameworks. I want to talk about specific AWS services that we've used over the years and some newer ones that are now HIPAA eligible that can help. I want to talk in some amount of detail about how automation helps drive compliance and give some very specific examples and dive pretty deep technically there. And then we'll wrap up and everybody can get on with the day. So why is compliance important? Well, there are a lot of regulatory frameworks out there that we have to deal with, right? There's HIPAA, there's PCI, there's FIPS, FERPA, FSMA, there's CSA and ITAR, we've got the ISOs, we've got the SOX, we've got all the foreign regulatory frameworks. Many of you now have GDPR on your minds. So with all of these frameworks that are required for legal compliance, as we're starting to deploy applications that exist in the covered industries, we really need to think about compliance and what we're going to do technically to map to those required controls. Why is this important? So in the past year, there have been 477 reported HIPAA breaches. That's more than one every single day. So we've got all this technology, all these compliance frameworks, all these rules and regulations, and we're still leaking PHI, protected health information, every single day. In the past 2 years, 110 million Americans have had their healthcare information leaked. That's 1 out of every 3, right? So look to your left, look to your right. One of you has your healthcare information out there. It's really important to recognize why that is so important. Healthcare information, so an HL7 message, like the PID segment, contains not only your most personal identifiers down to your social security number, your names, any addresses where you've lived over time. It contains your next of kin, so the hackers know your family. So all of this information is devastating to you personally, but also leads to some unexpected side effects, right? So people can blackmail you, people can assume your identity, but also people are going and assuming your medical identity, getting opioids at pharmacies and contributing to the drug crisis. That's why medical records are 10 times more valuable on the black market than a social security number or a credit card number. Because of this, we're seeing a 320% year-over-year increase in the amount of cyber attacks against healthcare organizations. So it's clearly a problem that we need to address. Now, if you're a small or medium business, not even in the healthcare industry, chances are 50% that you will experience a cyber attack during your existence. It's even higher for healthcare organizations. The net effect of that is that 2 out of 3 SMBs that experience a successful cyber attack are out of business within 1 year. So we're going to get very deep technically, but I really want to make sure that everybody understands sort of the context that we're talking about. It's not just checking a compliance box. It's really about protecting information that is critically important not only to the people that your organization serves, but really to the life of your organization itself. We're in Vegas. Do you really want to roll those dice? The thing that you have to recognize when you start on any compliance program is that you are a target. And addressing the fact that you're a target is not a matter of simply putting up a shield and thinking that you're done. Compliance is continuous. It's a continuous process. We're going to talk about how to map those processes. We're going to talk in a fair amount of detail about some of the technical controls that AWS provides you to effectively build a compliance program. So in order to have a compliance program, you need things like checklists and dashboards that surface risks before they become breaches. You need measurable, repeatable processes that effectively address the underlying risks to minimize the chance that your data will be breached. It sounds like magic, but it's not. The answer is address it through compliance frameworks. So we're going to talk a little bit about compliance frameworks, and then we're going to dive deep into the technology around how to implement those compliance frameworks. So a compliance framework is a set of structured guidelines that effectively address the controls required by HIPAA, PCI, and all the other compliance regulatory bodies. We personally, for HIPAA, we like High Trust Common Security Framework, or CSF. One of the reasons is that it's been mapped. We've done a lot of the mapping, and High Trust Organization has done a lot of the mapping. So there are well over 1,000 controls in the High Trust CSF that have been mapped back to HIPAA CFRs, to PCI, all the way down to GDPR. So if you can effectively attest to High Trust CSF, you can map that and attest to all of the underlying frameworks. In fact, we like High Trust so much that we've spent a number of years mapping the services that we've built, Cloudticity Oxygen, which is our management platform, to all of the High Trust controls. And today, we released a product called High Trust in a Box, which effectively allows you to implement a technical framework to manage your environment on AWS and inherit the controls that we have already certified at High Trust. And on day one toward that High Trust journey, you're 50% there. So we can effectively take a 6-month, extremely expensive process and bring it down to about 6 weeks. And that's an example of the power of mapping the technical controls that you implement in your AWS systems directly to compliance frameworks in a way that is effective to both reduce your risk as well as attest. If you're in the healthcare industry, you have to become High Trust certified. 2 years ago, the insurance companies, the payers, put out a notice and said, within 2 years, we won't do business with any vendor who is not High Trust certified. About a month ago, during the High Trust conference, the providers did the same. So within 2 years, if you sell to the healthcare industry, you have to become High Trust certified. One way to affect a compliant environment is to build it that way from the start. Now, if you think about what's involved in creating an AWS account or set of accounts, it sounds pretty simple on the front, right? You create an account, you enter some information, you configure a VPC. But in order to have a fully HIPAA compliant account that complies with all of the necessary High Trust CSF controls, log management, log retention, log protection, there are many, many, many steps. We listed them out, hundreds of steps that you have to take. One theme that you'll notice throughout our hour together is that anytime we see a human performing these tasks, there's a likelihood of error. People make mistakes. Computers generally don't. So one of the ways that you can address automating your HIPAA compliance on AWS is to get it right from the start by removing the human from the process of creating the AWS account. So for example, we do things like use AWS step functions to orchestrate a complex series of Lambda functions that do everything from scratch. So there's no account at the beginning, there's a fully configured HIPAA compliant account at the end. And you can apply this technique really to anything you're doing on AWS. Any process or sequence of steps that you can map out and document, you can also automate. One of the beautiful things about AWS is that everything is accessible by API. And so anything you can do in the management console with your fingers, you can also do with code. In fact, AWS writes the APIs first and then implements them in the management console, so you can actually do more stuff via API or CLI than you can online or on the web. So here's a slightly sped up. It actually takes about maybe 6 or 7 minutes, but you can see how we have a step function that orchestrates a series of Lambdas that creates and fully configures an AWS account. And what comes out the end is a fully HIPAA compliant, High Trust certified account. Another thing that you can do to drive toward automated compliance is to really think about standardizing the way that you use AWS. And so you want to think about standardizing how your account is configured. You want to think about standardizing how you use the account. You want to think about standardizing how you execute deployments inside of that account. And then you want to think about surrounding it with all of the supporting services that lend themselves toward surfacing risk and allowing you to address the risk before it becomes a breach. So, we'll start with standardized account configuration. Now, you've all seen this diagram 1,000 times. I'm not going to spend any time on it. It's a VPC with multiple AZs and public subnets, but most of your compute resources in private subnets and accessible through ALBs or ELBs or NLBs, right? So we know this. You can automate that. This shouldn't be configured manually. But the real magic comes when you start to think about the ancillary services that assure compliance. Compliance on day one is great, but configuration drifts. And catching that configuration drift, proactively operating on that configuration drift, preferably automatically, and remediating anything before it becomes a problem is critical to automating your compliance around HIPAA on AWS. So one of the first things that we look at is, how do you use CloudWatch? So CloudWatch is interesting. It lets you know CPUs that are running hot. It lets you know how much EBS you have out there and what your network flows look like. That's great. Not all that interesting, really. What's interesting about CloudWatch are things like CloudWatch logs, where you can push any type of log. So you can push your application logs. You can emit custom CloudWatch metrics from your applications. And you can trigger automated workflow from that. So for example, your application can emit a custom CloudWatch metric every time a failed login attempt happens. Now, one failed login attempt is probably not a hack. It's probably, somebody fat-fingered the keys. But 10 failed login attempts using the same username in a period of 2 minutes, that might be something you want to address. And by the way, that scenario maps directly to certain high-trust controls. So by using CloudWatch in an expanded capacity, you have the ability to sense and then respond, because it can trigger things like Lambda functions or SNS topic notifications, to sense and respond to events not only inside your AWS environment, but inside the applications that are running inside of that environment. Another service that is absolutely necessary and doesn't come turned on by default, nor even when you turn it on does it come configured by default, is CloudWatch, or CloudTrail. So CloudTrail fills an S3 bucket with a record of every single API action that happened to your account. So anytime somebody configures something, changes something, deletes something, there's an associated CloudTrail record turned on, or emitted. So, first best practice with CloudTrail, turn it on in every region that you use, and if you're not going to use a region, disable access to that region. If you say, I'm never going to push anything, to Europe, but you leave that region accessible, there's a likelihood that at some point somebody's going to make a mistake and configure a resource out there, and you're not going to know about it. So put it in every region and shut down regions that you're not going to use. The next thing is the way that you configure the S3 bucket that contains the CloudWatch information, the CloudTrail information. So you need to make sure that you have encryption turned on. You need to make sure that you have hash functions turned on. You need to make sure that you've got object versioning turned on, because one of the vectors that attackers use often is to perform a malicious action and then go back and change the log entry to cover their tracks. You also need to turn on MFA delete, so that if I do something bad in the account, I can't subsequently go delete the underlying record and hide my trail. So those are some examples of something seemingly so simple as enabling CloudTrail actually involves a number of steps in order to implement it effectively and in a way that attackers cannot get around the protections that it affords. Finally, CloudTrail just puts a record there. So it's much better to do things like trigger a Lambda function when that object arrives in the S3 bucket, examine the log file and determine if something bad may have happened and respond to that, versus wait until a breach happens, then have to dig through your CloudTrail logs. So enabling proactive views into the real-time current use of your account through things like CloudTrail analytics in real time is very important. Things like Service Catalog, Systems Manager, IAM. Configuring IAM is another critical piece. So when you deploy an account, you want, through automation, to have a predefined set of roles, called, in this case, we're talking about groups, so sets of permissions that identities can use. The other thing that you're really going to want to do is configure federation and SSO. In order to manage multiple IAM identities that are attached to a single person across multiple accounts is unmanageable and will eventually lead to a mistake, which will lead to a breach. GuardDuty is a relatively new service that uses machine learning to implement a number of technical controls that identifies potential malicious activity. So port scans, malicious network activity, unusual ports, unusual network sources of traffic, and an ever-expanding set of controls, I think there are about 17 now, that again map directly back to high-trust controls, map back to HIPAA controls. That's a critical piece to implement, not turned on again by default. And again, not only do you want to not only do you want to be able to see what happened in the past, but you need to configure automated response when an event occurs. Flow logs are another critical piece. We'll talk a bit more about what you can do with flow logs, but that's a record of every single TCP/IP packet that traverses your VPC. Again, you want to enable that in all of your VPCs. In order to do that, you want to do that through automation. You want to create your VPCs through automation that automatically enables flow logs. And you want to protect the location where those flow logs go. In this case, it's going to be emitted to CloudWatch logs. And we'll talk about some techniques that you can use to do sort of real-time analytics on those flow logs and identify potentially malicious activity. The final piece is AWS config. AWS config, number one, lets you see a record of changes over time. So you're going to definitely want to be able to identify forensically how an account evolved over time, to look at configuration drift. The other thing you can do with AWS config is define a set of rules that automate actions. So for example, one good practice in HIPAA is to ensure that each EC2 instance is annotated with a defined set of tags. For example, is this a development or a production machine? Does it store, process, or transmit PHI or not? So you can describe the risk of each resource in your account, and then you can act on that risk. So you can build an AWS config rule, for example, that says, are all the proper tags attached to this resource? And if not, notify somebody, or in the extreme case, terminate the resource. You can identify if it indicates that it does store, process, or transmit PHI, are all the EBS volumes attached to it encrypted? And if not, you can automatically affect encryption. So by leveraging the power of AWS's ability to inspect itself and provide indelible logs of configuration changes, as well as proactive notifications to code, to things like Lambda and SNS, you're able to automate a highly compliant environment that is extremely unlikely to result in configuration drift that could result in being out of compliance or even worse, a breach. So some best practices around other AWS services that are relevant. So one thing that we really like to do is to build hardened AMIs. If you're working in the world, for example, of healthcare, the typical AMI that would be fine for a website is not necessarily going to be fine for you. And so there are certain best practices prescribed by CIS, for example, the Centers for Internet Security. They've got a set of profiles that you can look at AMIs, you can look at running instances and identify whether they're properly hardened or not. We'll talk about ways to automate that. But using predefined AMIs that have been vetted and hardened is a critical best practice to reduce the attack vector, the surface area that introduces risk into your environment. Use of AWS Service Catalog. So we've talked a lot about how in a healthcare environment, you need to use things like tagging. You need to use things like extra configuration to ensure that you've got compliant resources. You need to make sure that only hardened Omnis are deployed, that they're tagged properly. To rely on humans to do that is a mistake because people will eventually make a mistake, and your overall security footprint will be diminished. Service Catalog is an AWS service that lets you deploy a predefined stack and do so in a way that you don't have to have excessively promiscuous permissions to the AWS account. So you can give a developer the ability to deploy an entire development stack from soup to nuts automatically without even having permissions to spin up or spin down EC2 instances. And Service Catalog is the way to do that. One thing you might consider in using Service Catalog, though, is to reduce the granularity of the services that you deploy. So instead of deploying an entire stack, use Service Catalog to deploy a single EC2 instance or a single security group and have that pre-configured to be compliant upon deployment so that it's literally impossible to deploy a non-compliant resource. And then if you want to compose larger stacks, you can simply use those primitives that you've built to continually expand, and grow a full stack of guaranteed compliant resources. AWS Systems Manager. The state that you want to get to in a compliant environment is where nobody ever logs into an EC2 instance. Number one, logging into an EC2 instance requires ports open that are dangerous inherently. And those are the ports that most attacks probe, and sometimes they successfully get in there. But number two, if a developer is in on a production box, especially during, say, a production outage, they're going to change a bunch of stuff and try a bunch of stuff and open up a bunch of security ports, and they're never going to close that stuff back down. So best practice is to just say nobody ever logs onto an EC2 instance, close those ports, and use external management tools if you need to access that instance for configuration purposes or patching purposes. So Systems Manager is a great way to do that. And finally, CloudFormation. All of the resources that you define in your Service Catalog are defined through CloudFormation. And so you can use it to define pre-vetted configurations and deploy them through automation. The next thing we talked about is standardized deployments. So if you have this beautifully configured, absolutely hardened environment, and then you start manually copying code out there without process, without ways to vet the code, to make sure the code is secure, to identify potential challenges with the code, now you've introduced tremendous risk. And in some cases, you've introduced illegal risk because certain FDA-approved deployments, for example, have to meet certain standards. And so you have to be able to automate the deployment, audit the deployment, and prove that the deployment takes place the same way each and every time. So AWS has a set of services designed to facilitate the building of extremely complex code pipelines that can not only pre-lint your code, run it through static security analysis, all the way down to build a container, run automated tests. Trend Micro just released some new really cool tools that will do a probe inside of a container to determine if the container has any known security risks. Lots and lots of things you can do when you automate the full process of deployment from start to finish. And the really interesting thing is you can do the same thing with your infrastructure. You can use the code deployment tools to actually manage and deploy your infrastructure. Finally, there's a whole additional set of AWS services that can be invaluable as you drive toward a compliant environment. Things like guard duty, which again uses machine learning techniques to watch for problematic things. Things like step functions, which can automate series of lambdas. So as you come up with automating your checklist of processes, you can use step functions in Lambda to orchestrate that. Things like API Gateway, Kinesis Data Analytics, We'll show in a bit. We talked about how you can do real-time data analytics on things like VPC flow logs. So data analytics allows you to look at streaming data and analyze it for things like anomalies using unsupervised machine learning models. Things like key management service to ensure that you're doing proper key management, key rotation, to ensure that you're logging every access to key so you know every encryption and decryption that took place and who did it. Things like managing access to keys so that people who shouldn't be able to decrypt things can't. Proper configuration of S3. There have been a few public breaches, and AWS has had a tremendously strong response, a positive response to things like S3 buckets that were inadvertently left open, which caused data breaches. Good hygiene in your practice around S3 is critical to having a strong compliant footprint on AWS. AWS even has what they call Trusted Advisor, where they look at your account from perspectives of security and availability and performance and cost and make proactive recommendations. And that is available by API. So you can actually build automated systems that receive information from Trusted Advisor and act accordingly. You've got SageMaker, which introduces machine learning so that you can do things like analyze the use of your application and determine proactively and immediately if it's being used in a way that is unusual, or if you see unusual data flows that might indicate PHI exfiltration. So all of these services are available natively on AWS. The output of this can become pretty interesting. So you can build things like a flow log analytics, which is built 100% using AWS native services, not paying tons of money to third-party log management services and that sort of thing. So here we've taken VPC flow logs in real time, run them through API Gateway and Lambda, and geolocated them. So we append information about latitude, longitude, city, state, country, that sort of thing. Run that through Kinesis, which does an unsupervised machine learning algorithm using random cut forest to identify anomalous network traffic. So if we see something like an IP address in North Korea sending data or probing, we can respond automatically by putting an ACL on that subnet and shutting that down immediately. So you can use native AWS services and full automation to dynamically affect a significantly more secure environment. We can also do things like dynamically look at the overall footprint by querying APIs and looking at things that look like they are not compliant. And the critical piece here is that every one of these controls is mapped back to a specific HIPAA regulation. So we can address an auditor's question immediately. And if something drifts out of compliance, we can trigger workflow and manage that automatically. So how does automation help compliance? One way that we look at it is that Carbon people are fallible. And when you do all of the hundreds or thousands of things you need to do to maintain compliance, the fallible people are going to make mistakes and you're going to drift from compliance. Silicon computers don't make those mistakes. And so we like to focus on automating as much as we can to ensure that our systems remain compliant without having to involve lots and lots of people who are likely to make a mistake. So we can do things like automate remediations. So I took this screenshot last week. This is on any given day. So that's our help desk. On that day, 63% of the help desk traffic was remediated through automation. So no human ever touched it. So the system identified a challenge or a drift from proper configuration. It automatically opened a help desk ticket so that we have an end-to-end log of the incident. It triggered remediation and automatically closed that ticket. So full end-to-end compliance without ever being touched by a human. And the really cool thing with this is that all of these tickets are logged so that over time you can feed machine learning models that let you make your predictive systems more accurate. So tickets that maybe shouldn't have been opened in the first place now don't have to be opened anymore. We talked before about building those golden AMIs, the hardened images. You can automate that process. You can receive an SNS topic notification when AWS publishes a new AMI. You can use things like Chef Inspec to run it automatically through CIS profile checks, remediate, iterate over that until you finally have a hardened image that you can deploy, and then we notify an SNS topic again so that all of our customers can trigger their CI/CD processes and update their systems with the newly hardened image. So through end-to-end processes like this, we can affect continuous compliance, map it back to the compliance frameworks, and lower our risk profiles, protect customer systems, protect patient data, and satisfy regulatory requirements. So, thanks for coming. We have time for a couple of questions if anybody wants. Just really quick, if anybody's interested, we're throwing a pretty big party tomorrow at Canaletto at 6 p.m. If you drop your business card in a fishbowl, we're giving away a pretty cool drone. And if you wear any of the Cloudticity swag, we got a little door prizes. So, any questions? Yeah. You guys do anything for SOC 2? I'm sorry? So we do SOC 2 indirectly. Everything that we do is mapped to the high trust CSF, and then you can use those mappings to SOC 2 controls. That's a subset. Sorry? The SOC 2 is a subset of. Exactly, yeah. Yeah, high trust is sort of a superset of that. So yeah. Yeah.
So you talked a lot about automated infrastructure deployment and updates.
Yeah. So good question. The question is, how do you remediate compliance challenges with long-running systems like databases? So that's generally done through a combination of patching, which can be interesting, right? So if you have a database cluster, patching is quite a process, right? You have to patch the secondary node, fail over, patch the primary, fail back. There might be a multi-step because you may have to validate that the patches don't break anything. Again, it's all automated. You know, we've written code that will automate that. You can write code that automates it. So in general, we don't like patching because we like ephemeral infrastructure that you can kind of tear down and build back up. But there are long-running processes that will need to be patched. The other way of protecting that is to use an agent-based risk remediation system or intrusion detection prevention system that will essentially apply virtual patches, where you don't actually have to patch the operating system, but it will detect and prevent any of the vulnerabilities from taking place. Yeah? What do we do about retiring an AMI? We generally don't. Other customer systems might depend on it. They might have an auto-scaling group that, that references that. But we will definitely publish that we've got a new AMI, and we'll identify the CVEs that it addresses so that at least there's an indelible record of the vulnerabilities that now exist in those older AMIs. Yeah. Okay, I think that was it. Thank you very much, everybody. Have a great reInvent.